Now, indeed, today was really not a good day because I work in the morning, and I decided that today I'm going to record this paper for AS Physics Paper 3 Practical. So what I did, I set my setup, then only to find that after recording for 1 hour 50 minutes, there is no audio. So decided to leave the video completely, but I said I have to find a way to ensure that this information I wanted to pass and record can reach to you so that you can be able to learn. So that's why you see I'm having Mr. Nick on that ready to start teaching, and I'm here explaining exactly what Mr. Nick did, and there was no audio recorded. So I've decided to add this particular tutorial so that I can be able to add the audio. I talk through what Mr. Nick was teaching in the morning, so that at least you get to know what you're supposed to do as far as practical paper 3 of AS Physics CIE is concerned. So if you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to upload any tutorial, you'll be notified. We're going to have a discussion on how the structure of paper 3 looks like and what you are supposed to do in that paper, and how you are able to earn your marks, all your marks, as far as that paper is concerned. So here you can see with me here, I have a paper of practical skills 1 for paper of 2023. This paper is 40 marks, and how you are going to work it out really matters a lot, and the way you are going to answer questions matters a lot. So you can see one of the questions that we have here, there is a setup we are supposed to set. Just follow the diagram the way it is in the paper so that you can be able to put up the apparatus together in order to earn that marks, because there's nothing complicated here. You just follow the diagram the way it is so that you can be able to set it up and then start taking the data. So setting up the apparatus, just follow step by step the instructions given in the paper and the way the setup is in the paper so that you can be able to see what you're supposed to do. So in the process of working out that paper, we are going to look at how do you take measurement, how do you record measurement. For instance, when you are taking a measurement, you are going to use either a meter rule, you are going to use a protractor, you are going to use a vernier calipers, and now the number of significant figures you are going to use is key because the examiner will be checking that. Now for instance, you see here there is a length that is provided. Yeah, they are telling you approximately 53 centimeters. This length 53 centimeters. So why are they telling you approximately 53 centimeters? And again, they are telling you to record that reading down here. So you see, the main reason as to why they are telling you to record that is to check whether do you really understand the number of the number of decimal places when you are taking a measurement using a meter rule. So that's why when you are recording this measurement L, you are going to record correct to 1 decimal place. And that is exactly what Mr. Nick was explaining when he was doing this particular video in the morning. So he said whenever you are taking a measurement, for instance, if you are measuring a measurement C, a measurement D there, you are supposed to remember that using a meter rule, you record to 1 decimal place. For instance, if you got 12.5, it has to be 12.5. But if you take measurement and you get exact value, like you get 10, you get 5, you get 4, like this 5, you cannot record 5. You have to put that decimal place in order for you to earn that particular mark. So that is very key, that is very important. There are other instruments that you are going to use in other experiments. For instance, maybe if you are measuring angles, let's look at this paper of 2024. You see which measurement was supposed to be taken. Let's see which measurement was supposed to be taken here. Let's look at it so that you can see that these questions are always the same. So if we are talking about this measurement L, maybe it's being recorded here. you have to record it correct to the 1 decimal place. If you are taking the voltmeter reading, you can see here, you record the way whenever you are taking a voltmeter reading from a voltage. If you are taking a voltage reading, remember you are going to take it the way the voltmeter is indicating, then you can be able to record. So but what I'm insisting, when you are taking measurements for meter rule, you have to record it to 1 decimal place, right? And let's see what further you need to focus much on. Now looking at further, if you are talking of a protractor you record to the nearest degree. What do we mean? If you get 30, you say 30. You cannot record a protractor reading as maybe 40.1. No, it has to the nearest degree. Then we can talk of a micrometer, screw gauge, and a vernier calipers. Those are recorded correct to 2 decimal places. Sorry, this has to be corrected. That should be no, I have to change that. That's to 2 decimal places. Yeah, so a vernier calipers and a micrometer screw gauge is to 2 decimal places. But the difference between a vernier calipers and a micrometer screw gauge is that a vernier calipers records in centimeters. When you take measurement using a micrometer screw gauge, you take it in millimeters. So that's the difference. But the number of decimal places has to be 2 for a vernier calipers and a micrometer screw gauge. Yeah, so those are some of the aspects that Mr. Nick was really talking about in that particular video. I believe that whenever you are going to be given questions now, you will be in a position to answer. So once we have identified that, now we shall talk about the table of values, how to fill the table. Now what are the number of significant figures that you are going to record. Now for instance, we have a setup, this setup here, we have some data being recorded there, and remember you have to stick to the number of significant number of decimal places for that instrument that you're using. For instance, if you are measuring distance, you see I'm having 4.0, I'm having 6.0, 8.0, 10.0. 0.0 is there to indicate which instrument I used. For D here, D measurement, that column of D, you see I'm having 13.3, 14.2. But now when you are going to fill in the column for calculations, maybe you want to calculate D over S. How many, which number of significant figures are you going to record that part of the table? So that is exactly what we are going to focus in the next part, so that we can be able to see. For instance, if you are doing D squared, how many significant figures are you going to record? Yeah, so when you are calculating data values in a table, you record the number of significant figures based on the raw data. For instance, if the raw data there, D, was in 3 significant figures, then D squared must be recorded in 3 significant figures. So basically that's what you have to put into consideration. And then I did a very interesting diagram there, trying to figure out an experiment. If you are given experiment there for springs, maybe you are given point B and there is another height you are supposed to measure there, and then there is a mass that is being adjusted so that you can be able to take different measurements. So you see, if you are told to measure the height h, you are going to do what? How are you going to measure the height h? Let's look at that. So for instance, you are supposed to measure the height h and the length x. So what are you supposed to do? For instance, for you to measure the height h, which instrument are you using? You are using a meter rule. So that should be recorded correct to 1 decimal place. Yes, so that's why I recorded that as 19.1 centimeters. For x, if we are recording that distance x, also we are using a meter rule to measure that, and then you record it. Maybe if you got 10, you have to write it as what? You have to write it as 10.0 so that you can be able to get that mark. So failure to do that, it's going to be catastrophic, it's going to be dangerous, it's going to be messy during the marking of your paper. So make sure you are following that instruction. Now I want us to move straight and get to see, when it comes to a table, how do you fill in the table, and how many data values do you really look at. Now I want to go straight to the paper so that we can be able to see the instruction, how the instruction is usually given in the paper, and adjust the position of the paper clip. Okay, all right, that one is done. That is the first section. Okay, now you are told vary L. You are going to be told what to change, and then get you until you have 6 set of values. So the 6 set of values, we are not going to include whatever that we have gotten here. Now, so we are not going to include the other set of values that we had gotten. We have to come up with new 6 values so that we can be able to fill in our table. So in that case, you see here we are told 6 values, so your table must have 6 values, and record in your result, and your table should include 1 over L and 1 over V. Okay, that is the year 2024. Let's check another year. I get to see, are this question really going to be any different? You see, taking that measurement for L, ensuring the number of significant decimal places are correct. Okay, let's see the question that follow. You should not be scared for this exam, should not. Now you see, change S in the range of 5 to that by adjusting the position. Record 6 set of values. You see now also here we are having another instruction that we should record 6 sets of values, different 6 set of values. So basically that's what we're going to do in the exam setup so that we can be able to see. Now, are we told here the number of what should include? Yeah, you are told also record your result in the table, include the values of, so this one are the calculated values, so which means we are going to record S and T, then our table should include the whatever that we are trying to calculate at that given point. Also, let me just look at this table that we are having at this point. No, this was the paper 2 of vape merge. Yeah, so if you've right, all right, yeah, so no, this is not, yeah, this one now. Okay, you see now in the experiment that I was trying to explain there, you are supposed to set the apparatus as shown here, then adjust, measure X, measure height. Okay, let's see. This height has to be recorded in the correct number of decimal places. I've already mentioned that. Now, lower boss A while keeping B the same with the point where it was. We were told that. And now, include in your table, you should have 6 set of values and include 1 over H and X over H in that. So that's why I'm still insisting that always just follow the table the way it's instructed there so that you can be able to have the entire data. Now, that's the experiment I was really talking about, and now adjusting the values the way we were being told. We were supposed to move A down so that we can vary the height H and also adjust the mass so that we can be able to see where it's in equilibrium. Now we can record H. In our table, we have to ensure that we are going to include the units. See, in the column of the tables, ensure that the units are well indicated. Now you can see here, we are going to do 1 over H. 1 over H. So how are our units going to be? Because we are having 1 over a centimeter, 1 over a centimeter, so we are going to ensure that when we are recording the unit there, because we have to use that slash bar, yeah, so that bar there, so that we can be able to separate the quantity and the unit. So that's going per centimeter for that column of 1 over H. And also we need to realize that this section of H or X over H is going to have no units. There are no units because that is a ratio between different lengths. So it's very important. Mr. Nick was explaining in your table, you should include the units in each of the column, and then whenever you are going to record, you have to ensure you are recording to the correct number of decimal places when you are taking the measurement, maybe using the ruler. And then also you record for X, ensure that you take the measurement correctly, and then from there you are now able to use your calculator to fill in that column for 1/h. So that's an area that I was really focusing on, to ensure that you remember whenever you are going to put that in your calculator, the final answer will be recorded there. Just you can see we are having 1/9.6, right? We have to record that to the correct number of significant figure in the table, and the number of significant figures should be the number of significant figure of the raw data, same number of significant of the raw data, or one more. So in that case, I decided that if the number of significant significant figure in that it was 2 significant figures, then I record that as 0. What? I record it as 1/0.96. I record it. Yes, I put in the calculator, and ensure your calculator is all right. So we need to record that, and we shall record it as 0.10, right? So we shall record it 10, correct to 2 significant figures. Then we do for the second one also, that is 7.5, and we check that, and we agree that 0.13, 2 significant figures. You do for 6, you do 5.4 also, and you have to ensure there is uniformity in the number of significant figures the way you are going to record your table. And we said we are going to do the same for X/h. So and now that's the point where it was getting interesting. Mr. Nick was asking there, whenever we are talking of 2 variables here, we are having X and we are having H. That was what he was talking about. I remember very well. Now, whenever you are having 2 variables and you are calculating a value from there, remember, one is in 3 significant figures and another one is in 2 significant figures. So when you are filling the table, which one are you going to use? Which one are you going to use to record that calculated value? So we had a bone of contention there, and we agreed whenever you have 2 values, you have to take the least number of significant figures or one more. So for uniformity, you can decide throughout, you take the least number of significant figures so that you earn your marks like that. So let's see how it went there. So we are having this one and that one. Which number of significant figures are we going to use in that case? Let's see. Nick sat down in order to decide which one. X is having 3, H is having 2 significant figures. So which one are we going to take? Nick wrote NB, point to take serious, as if your life depends on it. So we are having 2, so we can, H is the least number of significant figure. H has the least, which is 2 significant figures. Then you have to take that one or one more. So if a student recorded 3 significant figures in that column or 2 significant figures, that student was still correct, right? Right, so we can now ask Mr. Nick to be a bit faster so that we can be able to record that. So what was Mr. Nick showing us there? Bro, what are you showing us? Can you talk to us? Yeah, so he has no microphone. He had no microphone, so we could have heard what he was talking about. All right, so this one, let's record in 3 significant figures, because we have said you record least or one more. The least is 2, so if you take one more, that will be 3. So I decided now in this column, I will record in 3 significant figures, beautifully like that. Then we shall now proceed like that. Proceed, record every value. In fact, it was really quite disappointing that I record a video for 1 hour. That means there is no audio. I was having my microphone here, yeah, recording, talking throughout, only to realize when I'm hitting stop recording, when I'm done with everything, that's when I realized that video recording but no audio. It was really very sad. But I said, whichever way I can be able to make this setup so that this video can come up, I believe you are getting value, you are getting to learn exactly what you are supposed to do. Whichever way, we are achieving the objective so that you can be able to get that A star that you really deserve. Now we have completed the table, but there's something really not okay there. Okay, let's look at that. We were told how many values? We were supposed to do 6 set of values. How many did Mr. Nick do here? 1, 2, 3, 4, 5. Oh, 1 was forgotten. 6 set of values. Okay, yeah, for us to draw the graph, we needed 6 set of values. So Mr. Nick, can you go back? Can you go back and do that? Mr. Nick, you need to go back and do that. You have to go and correct and carry another extra value. So Mr. Nick is not following what I'm saying. Let's try to figure out what is being there. So whenever you are drawing a graph, let's go back to our question so that we can be able to see maybe instruction provided. So another question you are expected to do is to draw a graph of 1 over h on the y-axis. Now you can see even in this particular instruction provided, in fact you are not supposed to fail a practical, because they are even telling you what should be on the y-axis and what this should be on the y-axis, and x over h should be on the x-axis, already well demarcated there, so that you can be able to put everything in the correct axis. Please be very careful so that you don't really mess things up by inverting what should be on the y-axis and what should be on the x-axis. Ensure every time you know what's on the y-axis and what's on the x-axis, and on that x and y-axis you have to ensure that you indicate the variables. On the y-axis we have 1 over h, then we have to put a slash so that we can be able to put the unit. The unit was per second, per centimeter, but on the x-axis we are having x over h. Since centimeter and the centimeter cancels, we are not going to have any unit in that case there. I believe that is key, and that is basically what Mr. Nick was really explaining in that particular setup. And as Mr. Nick was really looking into that, he realized that, oh, so these guys were really calling me, and then supposed to use the data in order to draw the graph. So whenever you're drawing the graph, you draw a line of best fit. A line of best fit is where the most points of the line pass on the point that have been plotted, or those points are equally distributed. Yeah, so if you have a line of best fit, you have to ensure your line passes through most of the points, or your line is in such a way that the points are evenly distributed in either side of that line, so that you have line, so that you have line, so that you have the line of best fit. You have the line of best fit. And when you have the line of best fit, you don't draw a curve, bro. You are told line, so it means it's a line. So if you're seeing a question and telling you find the gradient, find the y-intercept, it means that's the straight line. So don't go there and start really messing me up, because I've already told you how to do this. If you're new to ProfLearn YouTube channel, consider subscribing so that anytime I'm going to do more tutorials, you'll be notified. Also do this to support ProfLearn, to support this channel so that it can be able to grow. You can share this video to most of your friends so that at least they can also be able to learn. So this is the Physics AS masterclass on how you are supposed to handle practical questions and what you are supposed to do in order to maximize the number of marks in your practical. If you found this video really helpful, like this video. Also leave a comment if there's something really you learned on how to go about as far as practical physics is concerned. So something also that Mr. Nick was really trying to show there, yeah, look at the way he's looking at you. There is a point he has circled. So if you realize that when you are plotting your graph, there is one point that is very far, don't be worried. Don't be worried. guys, I'm doing a practical down here, no worries. I'm doing a practical down here so that can get the energy to continue. Okay, you guys, let's continue. All right, so in this case, back after this short break. Now, that whenever you have there's a point that is really far from the line of best fit, don't be scared about that point. Just circle it to indicate to the examiner that that is an anomalous point. If you circle that, the examiner will know that was anomalous point in this case. So we have really discussed what we are supposed to do, and I think we need to move further and get to see what else is really going to be asked. So you are going to be asked about gradient, and you are going to be asked about the intercept. So how are you going to look at the intercept? Yes, so Mr. Nick is joining the points. You can see now when the line is extended, is cutting at a point. That point that we have here, for instance 0.13, that is the intercept. So we are going to say the y-intercept is 0.13. Will you earn the mark by just writing that? Will you earn the mark by just saying that? You will not earn the mark by just saying 0.13. You have to add the unit for the y-axis. The unit must be indicated so that the examiner can be happy for that. Now, whenever it comes to gradient, you have to ensure that you use almost more than a half the length of the line for you to draw that triangle, which will enable you to find the gradient. So don't just use a tiny section of the straight line for you to do that. Just draw a triangle, and in fact, let the triangle remain as an evidence that you worked out that particular gradient. Remember, gradient is rise over run, change in y over change in x. So you have to ensure that you are using more than a half of the length of that line, that line graph that you have obtained. So for instance, I chose a point there. At that point maybe is 0.14, and that point there is 0.23. And down there we have 5.00 and 1.99. So change in y over change in x is going to give us the formula for gradient. Now, once we work out that particular gradient, we have to subtract change in y, change in x, then you put that in the calculator for you to be able to get your value. Mr. Nick, can you go back and tell us which value did you get there? Tell us. Subtract, talk to us. So if you subtract, which value did you get as your gradient? Is it really clear? Okay, record for us that value so that we can be able to know the gradient. Okay, so working out the gradient, the gradient is 0.299. Now, does a gradient have units, or you are going to leave that way? You have to include the units for that particular gradient in order for you to state that. So let's try to see how do you get the units for the gradient. Remember, we were finding gradient y over change in y over change in x, but y was 1 over h and x was x over h, isn't it? X-axis was x over h. So but you see, the x-axis was not having units. The only unit that we were having are the unit for the y coordinates, the y values. So that will mean the gradient will have the units of the y value. So basically that's what we are supposed to do, and the gradient is going to be written like that. And you have answered that particular question, and now you see you are told to plot the graph, determine the gradient, and once you've done that, you will see there will be a section here. You write that gradient, and also you write the intercept. Now in this case, let me just record the gradient that we got and the y-intercept. Gradient we got as what? Do you remember? the gradient we got as 0.299 per centimeter, and the intercept we got it as 0.13, and we say the unit also in this case, the units will be per centimeter also. So it's important for you to include those quantities for you to work it out. Now, of course, I'm assuming the graph, you have drawn the graph there, and then we are having the section whereby we are given that the quantities in H are related by the equation. The quantities in H are related by the equation. So this is now the section I want to see. How are you going to answer this question? Let's go back and get to see how Mr. Nick is explaining that section on how to fill in those quantities and how to approach each of the section. I think space was not really enough. Mr. Nick really decided to quickly clean the board so that we can be able to have space, so that we can be able to proceed to the next question. So you can see is busy telling us question F. Probably question F in your exam will be this question. You are told there's a relationship like this, and then you are supposed to state the value of A and the value of B. So how are you going to answer that? It's quite straightforward, because you can identify whatever that Mr. Nick has circled, that we are going to use the relationship of y equals to mx plus c. So the x-axis you see was what? X over h. So x over h is the x values, and 1 over h are the y values. So meaning, if we are going to get a straight line graph, it will mean it obeys the equation y is equal to mx plus c, right? That is basically what he was trying to explain. So b is going to be the y-intercept, and remember from the previous section E, we have already talked about the y-intercept being 0.13. So our b is going to be 0.13, and our a is going to be the gradient. Our a is going to be the gradient which we had gotten, and our b is going to be the intercept, and that is per centimeter. Now you see this section that we are talking about here, you are basically copying the answers that you got from the previous question, because what you are basically doing here is just relating, you are relating whatever equation we are having here with y is equals to mx plus c. Now since on the y-axis we were having 1 over h, so that is corresponding to y, and we were having x over h, which is corresponding to x, then this a that we are having here is going to be the gradient of that straight line that we have, and this b that we have here is going to be the intercept. So meaning our a is 0.299 and our b is per centimeter. Don't forget the units. Most of the time students forget units, and that's how you will start losing marks, and you walked out of the exam smiling that you have answered all the question correctly, but because you are not keen with the number of decimal places and you are not keen with the units, once the exam come, you start cursing everybody. You start cursing everybody that somebody might have done something wrong with your paper, and maybe it's you who forgot issues of decimal places, issue of units whenever you are answering that particular exam. So basically that's what Mr. Nick was explaining that section, and he was really saying that you should never get those questions wrong because you are copying them from the previous section into this particular part. So we are going to move to the second question 2, and question 2, when I had a conversation here with Mr. Nick said is a fraud experiment with lots of errors, but we are going to focus on the main concepts and the main areas that are usually asked in that particular practical paper question. So now once you see, let me just see whether there's anything I need to really highlight in this part. Now we are moving to question number 2. Yeah, you see, also you'll be told to measure some distances, and whenever you are measuring any distance, also we said you have to write correct to this a specific number of decimal places, because if you are using, look, for instance, if you are using a meter rule, yeah, if you are using a meter rule, surely for you to measure that distance, it will include a lot of errors in the process of measuring that, huh? So but whenever you are measuring, maybe if you measure it to be 3.4, you have to say point so that you can be able to earn your marks. Now estimate the percentage uncertainty. Estimate the percentage uncertainty. This is the question that I really need to stress on, so that you are not going to make the worst mistake that some of the students usually make in this particular paper. Anytime you are doing a practical and you are talking about percentage uncertainty in question number 2, you are not going to work it out the way we usually do the theory paper, that you take the list, the precision or the least unit, divide by 2, then take the measurement over the measurement and times 100, you get the answer. No, we are not going to do that. I'm going to tell you the classical way you are going to do. So Mr. Nick here was talking about uncertainty, and that's the question I want us to focus on. So you are going to see questions whereby you are told to work out percentage uncertainty. I'm praying it's very hard, so that also this video is not going to really miss audio. So really pray so that it's not really going to mess me again. It was really bad. Now let's look at this, uncertainty. In this case, Mr. Nick was trying to say we have 2 springs attached in different sections there, and then one spring on this end and another spring on the other end. So the examiner required you to measure the angle between the vertical and one of the springs. Which instrument were you supposed to use in this case? Which instrument were you supposed to use? Yeah, which instrument? Yes, you'll use a protractor. And whenever you are going to use a protractor, you ensure you position it properly so that you can be able to measure that angle. Let's see what Mr. Nick did at this point so that we can be able to position it like that. See, Mr. Nick is dancing. Oh, okay, dancing because the springs were also dancing. The spring were also so you are going to take the reading, and the reading is going to be taken approximately because the spring was moving up and down. I saw Mr. Nick dancing here. So take more readings. So in order to work out, so you are told to record data, so you record it like that. Don't be so much worried about, no, just record it as accurate as possible as you try, because these experiments are about errors. So you just take a reading. Now, how do you calculate? Because the next question they are going to tell you, calculate the uncertainty of data of this measurement. That's the next question, because you can see also in the other question I was explaining here, calculate the circumference. Okay, no, but before that, estimate the percentage uncertainty of D. Yeah, in this question, I'm going to take you back to Mr. Nick's class. So here the student was supposed to measure this diameter and got 3.4 using a meter rule, and was supposed to determine the percentage uncertainty of D. So that is what we are going to see, how to answer such kind of question. Now let's follow how Mr. Nick did, so that we can be able to do that as an assignment, how to find the percentage uncertainty of D. So in this one, Mr. Nick said, for you to be able to find the percentage uncertainty, Mr. Nick, can you come back? What are you doing down there? So Mr. Nick said, take more readings for data. That's what he said. So also I'm telling you, whenever you are going to do that, take more readings for data and record them. Again, measure another one. Oh, measure another one. Oh, okay. Now next, what do? We are going to find the mean. So you add all the angles and then you find the average. Now put in the calculator. Now you see we are finding the mean of the angles we have measured. We measured only 1 data, but when you are finding percentage uncertainty, you will not be told to measure more. It's you who will do it. In that paper you will do it. If you are measuring distance, measure 3 more distances. Use that approach in order to find this particular angle here. So moving ahead, we are going to have 156, finding the mean. We are getting it as what? 52. Mr. Nick, what you are writing down there, and we are not able to see what you are writing down here. Yeah, can you move it so that we can see exactly what you wrote? Yeah, so once you have found the mean, also find the range. Range is the largest value, in this case is 54, minus the smallest, which is 50, so the range is 4. Then now uncertainty for this angle is going to be a half the range. So a half the range is 2, and percentage uncertainty in this case, percentage uncertainty, we have held it. The percentage uncertainty is going to be uncertainty, and uncertainty is half the range, and half the range is 2 over 52, which is the mean, which is the average. If we work it out, we are going to get our answer equivalent to what? Our answer become 3.8%. So that is the percentage uncertainty of that particular angle. So the summary is: find more measurements, find the average or mean, find the range, then use the range to find the uncertainty, then apply the formula that we have said here. Is that okay? All right, let's move to the next part, and we have our answer there. Let's see if anything Mr. Nick is having in store for us. Okay, I told you we have an assignment, homework. So let's look at this section we were talking about D here. So what was this student was supposed to do here? This student was supposed to take 3 more measurements. Don't take measurements that are again the same. So we can say 3.4. Again, take another measurement, 3.2. Again, 3.3. Okay, so these are the 3 measurements taken for us to find the percentage uncertainty. Then we are going to work out mean. So for you to work out the mean, you will say 3.4 plus 3.3 plus 3.2 divided by 3. So if you work it out, I'm just using my calculator there so that I can be able to see what I'm going to get. 3.3 plus 3.4 plus 3.2, I get 99, and this is going to be 99 over 10, which is 9.9. That's the mean. Oh my goodness. Hey, that's the mistake. Yeah, so I'll get 9.9. Oh, what's happening? This is 3 here because there were 3 data that were collected. So 9.9 over 3. So that is going to be 3.3 as the mean. So the next thing that you do after getting the mean is the range. The range is going to be the largest, which is 3.4, minus the smallest. So 3.4 minus 3.2, that's going to be 0.2. Uncertainty is going to be what? Is going to be 1 over 2 of the range. Our range is 0.2. So our uncertainty in this case is 0.1. Now, to work out the percentage uncertainty that we were supposed to work out here, what we are going to do is the uncertainty that we have percentage, and let me use U for uncertainty, is going to be uncertainty over the mean times 100. So that's going to be 0.1 over 3.3 times 100. If you work it out, our answer becomes 3.0%. 3.0%. So our uncertainty in this case is 3.0. So basically that's what you are supposed to do. And you can see the next question that follows is a scenario whereby you are going to use pi and d, but d is the measurement that has been taken in the previous section, in order to find another constant. Then the question that follows, justify the number of significant figures. Yes. Let's see, how do you approach that question when you are told to justify the number of significant figures? That is exactly, I think, what Mr. Nick is addressing here. And the number of significant figures should be linked to the raw data that was used. The raw data that was used. Now, in this case, Mr. Nick maybe was measuring length as 4.1 and the angle theta 50, was told to calculate the value of L sine theta. Then was supposed to put 4.1 times sine 50 in order to get that value to calculate. So upon putting that in the calculator, we are going to get our answer. Yeah, we put, ensure your calculator is not in radians, it's in degrees. Yeah, so that you get your mark. Yeah, so if I think here, what was Mr. Nick saying, if you are having two significant figures that are angle in two significant figures, and then the measurement L is in two significant figures, so the calculated value should have the same number of significant figures as the raw data. And then remember, whenever you are calculating a constant or a variable, when you are given different measurements, remember to include the unit. Now in this case, L is in centimeters, but sine theta has no unit, so you have to ensure that you write the units of whatever that you have calculated. So our answer, L sine theta, should be 3.1 centimeters. Because L is in centimeters, sine theta has no unit, so the unit of the calculated value should be that. So I believe that is key, and that is important for you to earn those marks, Now, how do you justify the number of significant figures? Mr. Nick, can you write something on that? Because L sine theta is in two significance. L sine theta is in two significance because I've recorded L sine theta in two significant figure because, Mr. Nick, can you stop joking? I've recorded L sine theta in two significant figures because L and theta were in two significant figures. So you have to try in a way to link your significant figures you have recorded after doing the calculation to the number of significant figures that were in the raw data you used to do this calculation. So basically that's what Mr. Nick was really trying to say there, and I think he's reading that for us. He's saying L has two significant L sine theta is in two significant figures because L has two significant figures and theta is in two significant figures, so the calculated value should have at least the same number of significant figures as the least number of significant figures of the calculated value, or one more. So that is how you are going to link in order to earn your marks. Okay, yeah, so moving further to the next part, and this next part that we are talking about is, does your result in the experiment support the relationship? You are going to see that particular question in quite most of the exam. So let's look at about justifying. Yeah, so you see now, whenever you are going to record, you are the way you are going to record your circumference. Yeah, so let's see how will you answer this question that we are having here. Suppose we are having 3.4. okay, so if we are having 3.4, for us to find C, we are going to say pi circumference pi d times 3.4. so if you put that in your calculator, let me just put in the calculator pi times 3.4, I'm going to get my answer as shown here. This is how I'm getting my answer. My answer is this, 10.68141 and so on. Am I going to record that really? I cannot record all that. So I have to record that value correct to the number of significant figures of the raw data that was used. This was in 2 significant figures, so I can record this to 2 significant figures or 1 more. So for instance, for me, I'm going to say 10. For me, I'm going to say 10. If I put 10 10 point, okay, that's very important for us. If you write like this, this is 1 significant figure. If you put a point like that, now that becomes 2 significant figures. But if you really feel unsafe to do that, you can write it to 3 significant, because this was in 2 significant figures, so you can write it in 2 significant figure or 1 more, so we can record it 10.7. so we can say 10.7, or we can just leave it at 10 points, so that becomes in 2 significant figures, right? In 2 significant figures, so 10 point. So what's the units in this case? The units of circumference is basically centimeters, so we are going to write in centimeters, my units in centimeters. Okay, now justify the number of significant figures. So we are going to say C is, let's write the way an A student could have written it. C is in 2 significant figures because it was calculated from where? From D, which was in 2 significant figure. So the calculated value should have the same number of significant figure or 1 more. So that is how you need to justify the number of significant figures like that. Now, let's look at another area that you will be seeing the exam, whereby you are asked whether just you check whether your result supports the relationship. That is another key and very important area that you'll be seeing in your exam. Now, for instance, you are doing an experiment and they give you a relation, or they give you a formula. They give you a long formula there or a short formula there, or a relation which will enable you to calculate different constants. Yeah, for instance, you have this formula here and you are told to find the first value of k and find the second value of k. They tell you find the first value of k, they tell you find the second value of k. So once you do that, you put all the values in your calculator to calculate the value of k. Now, for instance, here Nick did this and Mr. Nick got the value of k to be 27 and 25. Then the question that follow is that they are telling you that the uncertainty, accepted uncertainty, the uncertainty of K in this experiment was 3.8. This 3.8 I'm talking about here has no relationship in this value that we created, we calculated for data. No, it has no relationship. This is the disclaimer. It has just come by coincidence. Okay, so they gonna give you a different percentage. Maybe they tell you the percentage uncertainty of the value of K in this experiment was 25%. Can you check using your data whether this your result supports the relationship? Basically, there what you are supposed to do is to find the percentage difference between your two values of K. Percentage difference. Check whether is it going to be the same percentage they gave you, or is it going to be different. Okay, so let's go ahead and try to work it out. So in that case, you are going to work out the percentage difference of K, and percentage difference formula is usually K2 minus K1. Then we use absolute value over the mean of K, not over K, average value of K. You add the two values, K1, K2, you add them together, divide by 2 because they are 2, so that you can be able to do it that. So let us now go ahead and try to work this out by putting in the formula the way you have said. Yeah, so somebody is asking me, if I say K1 minus K2, will I be wrong? No. Even if you do K2 minus K1 or K1 minus K2, so long as you take the absolute. Absolute means what? The moment you get a negative, ignore it, take positive values. Okay, so moving on, you see the mean of K is going to be 27 plus 25 over 2, which is going to translate to 26, and then the difference is going to be 27 minus 25, which is going to be 2. Now we can now work out the percentage difference between the two values of K, and the percentage difference translate to 7.7%. Now we are going to compare this and that one so that we can be able to get say whether our answer supports. So if you get a different percentage, you say your result do not support. If you get the same value, you'll say your result support that particular relationship. Basically, that's what you are supposed to do in such kind of questions, in such kind of scenarios, in such kind of case. Yeah, explain whether your result supports. Yeah, I can see also there is another question looking at me here. Yeah, you see, using the values of first and second value, explain whether your results support the relationship. Now, in the event they don't give you any percentage that you are going to compare, you are going to compare that with the experimental, accepted experimental accuracy, and the accepted experimental accuracy in that case is usually what? Is usually 10%. Yeah, so you can be able to check whether your answer is more than 10% or less. If it's less than 10%, you say it supports. If it's more than that, you say it does not support. So it depends with the way the question is going to be structured, and for you to earn the marks, you need to follow those steps I've mentioned here. Now, the last section of the practical paper of question 2 is where you are supposed to state describe sources of uncertainty and the limitation of the procedure. Describe the improvement that you need to do in order to get accurate and reduce the uncertainty or the errors in that experiment. So in that case, you are not going to don't create problems and then you try to assume that you are solving those problems. You mention things that were beyond your things that were beyond your human nature ability. Okay, don't say that measuring the angle wrongly, who told you not to measure it correctly? Yes, so you don't create problems for you to solve them. ensure you are talking of limitations that there's nothing you could do. Yeah, challenges you really experienced when you are doing the experiment. For instance, this experiment that we're having here, you see, taking the angles where the springs are moving up and down, that will result to errors. There's nothing you could do about it. Yeah, there's nothing you could do about it. You see also, when you are measuring the angle there, you are trying to imagine where that particular vertical line is. So you maybe that could also result to the error. In that case, you are trying to imagine where that vertical line is, so that you can be able to measure angle in that particular direction. So there is one answer that is always universal for every practical that you are going to do in AS physics. One of the answer is that and that is exactly what we are going to mention here, is that two measurements are not enough to draw a valid conclusion. Two values are not enough to draw a valid conclusion. Immediately you are given a paper and you are supposed to answer question 2, you can write that as the first limitation, because always it's universal. Two values are not enough to draw a valid conclusion. The solution to that is taking more measurement, and you have to link now this measurement with whatever you are measuring the experiment. If you are measuring the angle and you are measuring maybe the value of L, you see, taking more measurement for L, take more measurement for L, and then plot a graph. That's how you solve the problem. So in this case, the first one, you can say two measurements are not. We can say here, we can come and record here that two readings are not sufficient and not enough to draw a valid conclusion. The solution: take more readings of that quantity that you are measuring and then plot a graph. Okay, according to this practical that we are doing, we can also difficulty to measure the angle as the springs were moving up and down, right? So how will you do that? You can be able to solve that by you can be able to use maybe a record. You can use a camera to record, so that you can be able to slow the motion. You slow the footage. You can be able to use a camera there, so that you can be able to record. You slow the footage so that you can be able to see where is this angle really, where is this angle. And also difficult to judge where the vertical line is. Difficult to judge. I was just trying to imagine there and then placing my protractor so that I can be able to see where my vertical line is. I really struggled to do that. You are just telling the examiner that I really struggled, and I was trying to see where's the vertical, where's the vertical of this angle where I'm going to measure here. Then how do you solve that? You can have a blump line in that vertical position, so that you can be able to know exactly where the vertical is. I believe if you have gotten value from this particular video, consider subscribing, so that anytime I'm going to add more tutorials, you'll be notified. And at the same time, let me take this chance to really wish you the best and the best of luck as you are going to do your exams. May you pass with flying colors. And if you have gotten value from this video, subscribe, leave a comment. If you have learned something to do, how to do practicals and how to answer questions, just share this video to your friends. Good luck and all the best. No, Nick, Mr. Nick, we are done. We are done. Now this is enough. We are done. All right.